Okay, this is another quick screencast looking at issues of efficiency, output, utilization, and other important topics that are associated with our homework that's due during the week. First of all, actual output is simply what your machines, your services put out as far as their overall production. The efficiency is that actual output divided by the effective capacity. And the effective capacity is that capacity that you have minus things like personal time, maintenance, those different activities that might take place. Then we have utilization, and our utilization is simply our actual output divided by what our equipment is designed for, or our design capacity. When we're putting together issues of efficiency and utilization, we've got a short example, and this is pulled directly from the textbook. You'll see it in our chapter 5. But we've got 50 trucks. Again, that's what our system is designed for. Our effective capacity, again, our capacity minus maintenance, those types of activities, 40 trucks. And then our actual output is 36 trucks per day. And so we can actually identify the efficiency and utilization based on those. Again, pretty straightforward stuff. Our actual output of 36 trucks divided by our effective capacity of 40 gives us an efficiency rating of 90%. By the way, I believe we multiply that times 100% in order to get that percentage. Our utilization, our actual output divided by our design capacity, what the system is designed for, or 50 trucks per day, and we multiply by 100% and we get 72%. As you can see, our utilization is always going to be lower than our efficiency, but both of these benchmarks, which can vary from one system to another, provides us an understanding of how we're doing from one set of activities to another. We also have another activity that's important for our work today, and that's really looking at some of the basics of cost volume analysis and break-even points. And I'd like to go over this for two specific reasons. One is it never hurts to go over this stuff, and then secondly, to introduce you to the QM for managers real quickly with regard to break-even point analysis. Fixed costs, FC, variable costs. I'm sure everybody knows what variable costs are. Those costs have varied from one product development to another. Total cost is our fixed cost plus our variable cost, and our total revenue is our revenue times our quantity. When we develop our break-even point, we really have two important equations to deal with. The first one is that our profit is equal to our quantity times our revenue minus our variable costs minus our fixed costs. And we can rework this equation into our break-even point, which is that point where total costs and total revenues are equal, or our fixed costs divided by our revenue minus our variable costs. We can apply these two equations that I just discussed, and again, this is the example from the text, old-fashioned berry pies. And we have leasing of the new equipment, $6,000 in a monthly payment. Our variable cost, $2 per pie, and our revenue per pie is $7. And we've actually, again, right from the text, they identify three important questions. How many pies should be sold in order to break even? What would the profit or loss be if we only made 1,000 pies? And how many pies must be sold to realize a profit of $4,000? The last two require us to do a little bit of algebra, but or at least equation manipulation. However, generally it's a plug and chug activity. 6,000 divided by our revenue, $7 per pie, minus our variable cost of $2 per pie, gives us a break-even point of 1,200 pies. What would be the profit or loss? Be if 1,000 pies were sold per month. We simply plug in 1,000 times our revenue minus our costs. 7 minus 2 is equal to $5 per pie, minus our fixed costs, and that gives us a profit of a loss of $1,000 for the 1,000 pies. And then how much or how many pies must be sold to realize a profit of 4,000? And again, what we do is we plug in 4,000 into our profit, and we want to know the quantity, so we solve for Q. Revenue is going to be $7 per pie, variable cost $2 per pie, and then we simply subtract our fixed costs. We solve for Q, and we're able to find our quantity that we need of 2,000 pies. As I had mentioned, I also wanted to just bring you to the, let me bring this over a little bit, QM for managers. And again, it'll do cost volume analysis. It'll also do break-even point for you. But simply go to Module, click on break-even cost volume analysis, File, New, and then go down to break-even analysis. Click OK, and as you'll recall, our fixed costs are 6,000, our variable costs are $2 per pie, our revenue per pie is $7, and we simply solve. Click on Solve. Let me expand this so it's there it is. And you can see that, let me see if I can move that over. You can see it'll run the numbers for us with fixed costs at 6,000, variable costs at 2, and revenue at 7. Our total number of pies to break even is 1,200. And our revenues are going to be $8,400. So the beauty of QM for managers is it does a lot of the math for us. It'll also allow us to do or present a graph. I'll pop that in so we can actually see the revenue, the volume, and then the break-even point, and it puts together the revenue line as well as our cost line. So it provides us a nice picture, a good presentation of our problem. I hope this was of value. Just wanted to do a quick overview, so thank you very much.